Welcome, history fanatics, to Mrs. Heron's video playlist, where you will get the best of the best in social studies. We're beginning with Unit 1, Where in the World Map Skills. The unit goal is analyze various types of maps of differing complexities. It includes Part 1 from Core Concepts, which is Tools of Geography, and Part 3 from Core Concepts, Climates and Ecosystems. In this section, we're studying the ways to show Earth's surface. By the end of this section, you should be able to answer the guiding question: how are maps different from globes? Imagine trying to flatten the surface of the Earth. It's simply not possible, because all of the countries and continents would be distorted or in the wrong place. This has been the dilemma of geographers for centuries, and it is the reason that we have to use multiple models to represent the surface of the Earth. Today, we will cover 4: globes, photographs, geographic information systems, and map projections. The first tool we'll look at is a globe. A globe is the most accurate depiction of Earth because it has the same round shape as the Earth. This means that continents and oceans will be true to size and location. The only thing that makes a globe different than the actual Earth is scale, or the relative size or extent of something. For example, 1 inch on a globe might be 600 miles in real life. Can you imagine how big a globe would have to be its actual size? Actually, you can, because you're standing on it. The second tool geographers use to show the Earth's surface is photographs. There are 2 types: aerial and satellite images. Aerial photographs are taken from very high, but not quite as high as space. Think helicopters and drones. This can show a lot of area at once, but not as much as a satellite image. Satellite images are taken from satellites in space that orbit the Earth. Photos are a great way to get a big picture of how an area looks, but they often do not have the ability to show like specific roads and locations, which is why most people still have to use maps. The third tool is essential to how governments operate cities, states, and countries. It's the Geographic Information System, GIS for short. These are computer systems that store information about the geography of locations. This is how trash collectors know what houses to pick up trash from, and how post office workers know which route they are on when they are delivering packages. These are also the systems that make Google Maps work and the iPhone Maps app work. They keep an enormous database of information about places and make them accessible to the public.
Why are we changing maps?
Because, CJ, the Mercator projection has fostered European imperialist attitudes for centuries and created an ethnic bias against the Third World.
Really?
The German cartographer, Mercator, originally designed this map in 1569 as a navigational tool for European sailors.
The map enlarges areas at the poles to create straight lines of constant bearing or geographic direction.
So it makes it easier to cross an ocean.
But
Yes.
it distorts the relative size of nations and continents.
Are you saying the map is wrong?
Oh dear, yes. Look at Greenland.
Okay.
Now look at Africa.
Okay.
The 2 land masses appear to be roughly the same size.
Yes.
Would it blow your mind if I told you that Africa is in reality 14 times larger?
Yes?
Here we have Europe, drawn considerably larger than South America. When it's 6.9 million square miles, South America is almost double the size of Europe's 3.8 million.
Alaska appears 3 times as large as Mexico, when Mexico is larger by 0.1 million square miles.
Germany appears in the middle of the map when it's in the northernmost quarter of the Earth.
Wait. Relative size is one thing, but you're telling me that Germany isn't where we think it is?
Nothing's where you think it is.
Where is it?
I'm glad you asked. The Peters projection.
The fourth tool is map projections. Just like the original video showed, there's no way to show the Earth's surface on a flat map or a photograph without ruining the original image. This is called distortion. That is why there are so many map projections, or ways to map Earth on a flat surface, available, and each of them have their own strengths and weaknesses. Let's have a look at a few. The equal area map projection has the correct sizes of continents and oceans, but the shapes are all messed up. The Robinson projection has the most accurate size and shape of continents and oceans, but the edges are slightly distorted. And finally, the Mercator projection, which is probably the most popular, has great directions and shapes, but the distances and the sizes among continents stink. Antarctica is not that big. This is a more accurate depiction of Antarctica. So the clear winner of projections is the Robinson.
But as long as we use flat maps, we'll have to deal with the trade-offs of projections. And just remember, there's no right answer.
To review, we discussed the models that geographers use to show the Earth's surface. These include globes, photographs, geographic information systems, and map projections. The definition from this section include scale, aerial photographs, satellite photographs, the GIS, distortion, and projections. And in the next section, we will apply all of this information to flat maps.